Concrete, one of the most ordinary things we see around us every day, yet one of the greatest inventions in human history. Roads, bridges, skyscrapers, dams, tunnels, homes. So much of our modern world stands on this single material. But the story of concrete is not modern at all. It is thousands of years old, filled with experiments, forgotten knowledge, rediscovery, and innovation. So let's travel back in time and explore the long and fascinating history of concrete. Our story begins in prehistoric times. Long before civilization as we know it, early humans discovered something interesting. When they mixed mud, crushed stones, burnt lime, or volcanic ash with water, the mixture hardened into a strong solid. Archaeologists believe that as early as 6500 BC, people in what is now Syria and Jordan used primitive forms of concrete to build floors, storage pits, and even houses. These early structures show us that humans were always searching for stronger, more durable building materials. Stone was strong, wood was useful, but concrete offered a unique magic. It could be poured, shaped, and molded into anything before becoming rock solid. As civilizations grew, concrete evolved with them. Around 3000 BC, the ancient Egyptians began using a form of mortar made from gypsum and lime to bind stones together. Think of the pyramids, massive structures requiring extreme precision and durability. While the core blocks were stone, the Egyptians used mortar to hold everything together. This wasn't modern concrete yet, but it was an important step toward it. The dream of shaping stone rather than carving it had begun. Then came one of the great turning points in the history of concrete, the Roman Empire. Around 300 BC, the Romans perfected what we now call Roman concrete, or opus caementicium. This was revolutionary. They mixed lime, volcanic ash called pozzolana, water, sand, and stone. Unlike earlier mixtures, Roman concrete didn't just harden, it became incredibly strong and resistant to cracks. Even more impressive, it could set underwater. This allowed Romans to build harbors, aqueducts, and seawalls that still inspire engineers today. If you've seen the Pantheon in Rome, you've seen the power of ancient concrete. Its giant dome, built nearly 2,000 years ago, is still the world's largest unreinforced concrete dome. No steel inside, no modern machines, and yet it still stands, elegant and solid. The Romans also built massive structures like the Colosseum, long roads, towering arches, and bathhouses. They even experimented with lightweight concrete by mixing in volcanic rock. Their creativity transformed architecture forever. Suddenly, buildings didn't just stack stones, they flowed and curved with imagination. But history is rarely a straight upward line. When the Roman Empire collapsed, so did much of the knowledge behind Roman concrete. Europe entered the Middle Ages, and while lime mortars were still used, the advanced formula of volcanic ash concrete was largely forgotten. For centuries, humanity stepped back to more basic building methods. Stone cathedrals and castles rose, but the genius of Roman concrete slept quietly inside ruins and broken manuscripts. The rediscovery began slowly. During the Renaissance, scholars and builders became curious again about Roman techniques. They studied ruins, analyzed materials, and experimented, but true modern concrete was still waiting to be born. Everything changed in the 18th and 19th centuries. In 1756, a British engineer named John Smeaton was tasked with rebuilding the Eddystone Lighthouse, which had been destroyed by fire. He needed a material that could survive waves, storms, and constant seawater. Through experimentation, Smeaton discovered that certain types of limestone produced stronger lime when heated. This step moved construction science closer to true modern concrete. Then, in 1824, another British inventor, Joseph Aspdin, patented what he called Portland cement. It was named after Portland stone, a popular British building stone, because the hardened cement looked similar. Portland cement became the foundation of modern concrete. It was stronger, more reliable, and could be produced in large quantities. Soon, the Industrial Revolution spread factories, machines, and railways across the world, and concrete followed. As cities grew and populations exploded, builders needed a material that was strong, flexible in use, and affordable. Concrete checked every box. But another breakthrough was coming: reinforced concrete. By the late 1800s, engineers began embedding iron and later steel bars into concrete. This created a powerful combination. Concrete resisted compression, while steel resisted tension. Together, they formed the backbone of modern architecture. Now, taller, wider, and stronger buildings were possible. The 20th century became the era of concrete innovation. Skyscrapers reached for the clouds, highways stretched across continents, massive dams like the Hoover Dam held back roaring rivers. Concrete was poured into every corner of urban life: schools, hospitals, stadiums, airports, and factories. It became a symbol of progress, modernity, and human ambition. Even wartime bunkers and shelters relied heavily on concrete for protection and strength. But concrete wasn't just about strength. Architects also used it for beauty: smooth curves, bold patterns, artistic freedom. Concrete allowed creativity and engineering to merge. Structures like the Sydney Opera House, the Burj Khalifa, and countless modern landmarks owe their existence to innovations in concrete design. Yet, the story does not end with success alone. In recent decades, people have also become aware of the environmental impact of concrete. Producing cement releases large amounts of carbon dioxide. As cities have expanded, concrete has covered landscapes, changing ecosystems and contributing to climate challenges. So today's engineers and scientists face a new mission: to make concrete greener, smarter, and more sustainable. This has inspired new kinds of concrete: high-performance concrete that lasts longer and resists extreme conditions, self-healing concrete that uses bacteria or chemicals to repair tiny cracks automatically, recycled concrete that reuses old building materials to reduce waste, even ultra-light and ultra-strong concretes for space-age projects. In some labs, researchers are studying how Roman concrete survived so long underwater, hoping to learn ancient lessons for the future. Think about it for a moment. From mud huts to megacities, from prehistoric villages to futuristic smart cities, concrete has quietly supported human civilization at every stage. It has been the invisible skeleton beneath our roads, the shield around our homes, and the foundation under our feet. And yet, it is still evolving. One day, concrete might build underwater cities, lunar bases, Mars colonies, floating structures that move with the ocean. The material that once shaped empires may soon help humanity reach new worlds. So the next time you walk down a pavement, cross a bridge, or look up at a towering building, remember this: you are standing on history. A history that began thousands of years ago with curiosity, problem-solving, and imagination. Concrete is not just a building material. It is a story of human progress, rediscovery, innovation, and resilience. And that story is still being written every single day.